That is a refrigeration cycle. Be prepared. All of your cycles have 4 parts: condensers, evaporators, engines, and compressors. So whether they run forward or backward, that's pretty much what the picture will look like. So now let me go into a little bit of detail before we do the Carnot cycle about these 2 things I talked about. Refrigerators and heaters. I should have made that picture later as well, but oh well. Good enough. So I'm going to call the 2 work to heat transfer cycles. And they use what is called refrigeration cycle. And so we'll leave room for 2.
All right.
Okay. And there are of 2 types. One is called refrigerators, and the other one is called heaters. I think I'm going to do refrigerators first.
All right, on that note.
Is it 0, 0, 0 or is it just 0?
You don't have that.
No.
All right, Dr. Zane.
Thank you. On that happy note, what's the main purpose of a refrigerator? Well, true. In terms of thermodynamics, what would lower the temperature? How do you lower the temperature? Lower T by, how do you do that? What do you want to get rid of?
Heat.
Removing heat. Excellent points. So what is that heat called for a refrigerator? It's called a cooling load. QL dot. Do we understand what the dot means? D over dt. And where do you want to remove heat from? From low temperature space to high temperature space. So what could be a low temperature space? Inside of the fridge, inside of a room. What could be a high temperature space? The room itself versus outside. Okay, all of those. Whatever that space may be. Cooling load, I think if you talk to a actual person who deals with heating and air conditioning contractor people, they won't call them cooling loads. Instead, I believe they call them tons of refrigeration. Like they call them in terms of tons. So if you look at your, have you ever bought a room air conditioner to put in the wall? It usually has a number on it. Tons of refrigeration in terms of tons. That's just the amount of heat that's capable of removing from the environment. So the heating cooling people will call this cooling load, the refrigeration effect, or tons of refrigeration. Just so you know. Now, we talked about ADA last time, two classes ago. What was ADA? Efficiency? You guys want to look at your... Remember that ADA, that funny looking symbol? What was efficiency? Benefit over cost? Good. So now for these kinds of, just to make our lives more interesting, we don't call these efficiencies. We call these the coefficients of performance. Or you will see it written as COP. And COP for a refrigerator is the desired output divided by the required input. Oh, actually, I should have made that black. Hold on. Or the cooling effect divided by the work.
When you say cooling effect, you mean that's just delta T?
No, just cooling effect is just QC. How much heat you want out divided by work you have to do in. And the cooling load is QL dot equals dQ over dt. L equals M dot H1 minus H4. So I'm writing this down, but it's the enthalpy change between this step and that step in a reverse Carnot cycle. And do you have a question?
Never mind.
Were you asking what H was?
No.
Oh.
The M dot,
M dot?
Yeah.
Yeah, what about it?
where do we get the M?
Ah, so do you remember Q was defined as MC delta T?
Yeah.
How would Q dot be defined? How much mass is being moved? Is C a constant? Is delta T a constant? Make sense?
Yeah.
Also, the values of the actual H1 and H4 are given in tables for every single working fluid that you will have. So that's something that we will not worry about. It's just a value you'll pick up from a table somewhere, depending on which particular working fluid you have in your refrigerator.
Sure, that's determined experimentally.
Yes. Mm-hmm. People have spent lifetimes doing that study. Okay. What about heaters? So what do you think the main purpose of a heater is? So its main purpose is, Andy, you were saying?
Raise T.
By?
Adding heat.
Good. So for case of refrigerators, we called it the cooling load. What do you think we're going to call this? There we go, right?
It's gonna be Q dot H, right?
There we go.
No. I mean,
What do we want to call it? Right? Low and high. So for this, the coefficient of performance will be COP. I'm gonna write it right in front of here. Right in front here. Okay, keeping this in mind, what do we think, what do we expect it to be? This is a heater, so I'm just gonna call it H. Is it still the desired output divided by the required input? Instead of the cooling effect, what would it be? There we go, divided by the work. So can I just skip one step and just call it the heating effect here? Divided by work in, or QH divided by work in. And the relationship between these two terms is given by COPH equals COPR plus 1. Everybody okay so far? Do we understand the difference between heating load and cooling load? They're just names given depending on whether we want to remove the heat or add heat. That's all there is.